Okay, so we're on question 3. Figure 4 is a diagram of an alpha particle and a helium atom. Here's an alpha particle. Here is a helium atom. What is the approximate size of a helium atom? So that would be the size going from right across here. This is one you're just going to have to remember, I'm afraid, and it's 1 times 10 minus 10 meters. In other words, 1 over 10 raised to the power of 10. So 10 times 10 times 10 times 10, 10 times. So it's a very, very small number. I'm not going to do it all. An extremely small number. So atoms are very small. Right, so if you haven't seen it, the original Powers of 10 little video, it's from the 1970s, goes up in powers of 10, so you can go from an individual atom all the way up to the galaxies, and this is the Simpsons doing the same thing, making fun. But I will put a link in the description. It's about 8 minutes long, I think, so it's worth a watch. If you're interested in this kind of thing, it's a genuine a genuinely accurate scientific video worth watching. Deep.
The picnic near the lakeside in Chicago was the start of a lazy afternoon, early 1 October. We begin with a scene 1 meter wide, which we view from just 1 meter away. Now every 10 seconds we will look from 10 times farther away, and our field of view will be 10 times wider. This square is 10 meters wide, and in 10 seconds the next square will be 10 times as wide. Our picture will
Pretty cool video, made by IBM. Click the link, have a watch after this.
100 meters wide.
Okay. A helium atom is much larger than an alpha particle. Right, so I can go back and refer to the diagrams here. Here's the alpha particle, here's the helium atom, right? You can see that the helium atom is much larger. Give one difference between the helium atom and the alpha particle. So spot the difference basically, right? And I can see on this side we have these things. What are they? They're the electrons. So
I should start with capital.
okay, helium atom has electrons. What is the atomic number of the helium atom in figure 4? Okay, so we have atomic number and mass number. And I have to remind myself, atomic number, is that the number of protons or the number of nucleons? Mass number is the number of nucleons, so I'm pretty sure that atomic number must be the number of protons. Go back to the diagram, you can see both of these are the same. Let's choose a smaller pen. Proton, proton, neutron, neutron maybe, or it could be the other way around, so it would be 2. What is the charge on the helium atom in figure 4? Explain your answer. What is the charge on the helium atom, this one, in figure 4? Right, let's go back to this bit. Explain your answer. Explain your answer. 3 marks. You've got to say a fair bit then. So, let's have a little look. If these are protons, and these are electrons and electrons, these are neutrons and neutrons, right? Then you've got to think that, well, neutrons, they don't have any charge, so their charge is 0. Protons have a charge of +1, and electrons have a charge of -1, right? These have a mass of 1 and 1, and the electron's mass is practically 0, or 1 over 2,000 approximately, so it's a very small mass for the electron. Right, so if you have 2 protons in the center, 2 positive charges, and you have 2 electrons, +1 +1, -1 -1, so if you're on a number line, and you went +1, so you went up to 1, and then plus another 1 up to 2, and then you went -1 -1, you're back to 0. So this is what this is getting at. Okay, so you have to say the helium
atom has 2 protons with positive charges. I should write the whole word. Oh gosh. And 2 electrons with negative charges. Full stop. This adds up to a charge of 0, to a charge of 0. Right, so hopefully I've said enough to get the full marks for that.
Okay, next bit. Helium gas that occurs naturally. Oh, sorry, helium is a gas that occurs naturally. There is very little helium left on Earth. Helium has important uses in medicine and can also be used to inflate party balloons. Some scientists believe that helium should not be used to inflate party balloons. Why? So this is not really something you can... it's not really a science-based question. It's more like an ethics-based question, I suppose. But they're basically saying, compare the uses. You know, why do you want to inflate party balloons, or do you want to use it in medicine? And there's not much of it. So
with a limited supply of helium, it makes sense to preserve it for medicinal uses. Or it makes sense to use it for medicine, not balloons, as medicine saves lives.
Right. I'm not confident I've got 2 marks on that. I will be checking afterwards and post and put a overlay on the screen. But hopefully I've got 2 marks. Okay, and that's the end. Alright, so thanks for watching. Please subscribe, like, share if you've enjoyed this video.